Okay, hello everybody. We're working on 12.3 today. You do need a calculator for this lesson, so if you don't have your calculator handy, stop the video and go get your calculator. Okay, hopefully you're all back now. Before I even start the lesson, I do want to go over special right triangles and the triples. Okay, so this should be review. Those of you that still don't know them, it's time. Okay, so actually, let me see where I can go to. Yeah, right about there. Okay. Let's do the 30, 60, 90 first. 30, 60, 90. This is the chart you should have in your head and be able to recreate. This is going to be x, x rad 3, and 2x. I'm not going to explain the whole thing again because we've done this. 45, 45, 90 is going to be x, x rad 2. All right, there's 3 triples that you should definitely know, and they are the 3, 4, 5 and all its multiples, the 5, 12, 13 and all its multiples, and the 8, 15, 17 and all its multiples. Okay, so if you don't know these, you need to make sure you learn them. Okay, all right, so let's start the lesson. Okay, so the first question says, find the length of the hypotenuse of a right triangle whose legs have the length of 50 and 100. Now, I can tell there's no triples there. All right, because I have a leg, and if I divide it by 10, that's 5 and 10, and that's not one of the triples, so let's see what we could do with this. So if I can't use a triple, I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Don't forget, I kind of like it leg 1 squared plus leg 2 squared equals the hypotenuse squared. All right, so we have 50 squared plus 100 squared equals c squared, or the hypotenuse squared, because we're finding the length of the hypotenuse, so I know that's the one I have to use. So I'm going to use my calculator and do 50 squared plus 100 squared. So I get 12,500 equals c squared. Square root on both sides. Now, let me get the calculator into the picture. All right, so I'm going to go into y equals and do 12,500 divided by x. And now I'm going to look at my table. Okay, I'm really far down. Sorry, I was doing something else. All right, because I always want to find the largest perfect square. Don't forget, you need to use the right-hand column. All right. I kind of like that one. All right, because 2,500 is 50 times 50. All right, hopefully you saw that. So when I simplify this radical, I'm going to put the perfect square on the left, as I always do, 2,500. And the other number is 5. So I'm going to take the square root of 2,500, and that's 50. If you want to double check that, go back into your calculator and do 50 squared, and you're going to get your 2,500. So I don't know if all of you saw that. I just kind of felt it. So the final answer is going to be 50 rad 5. Guys, please don't go decimal on this. Okay. Again, hypotenuse All right, I see 25s in both of those, but yeah, I'm not thinking I can get that one. So again, I'm going to use the Pythagorean theorem. So I have 75 squared plus 225 squared equals, I'm going to use the h here, the hypotenuse squared. And then I'm going to take the square root. I'm hoping you can notice this is like the distance formula. Okay, so 75 squared plus 225 squared and that's 56,250. So the square root of 56,250 will equal the hypotenuse. All right, this one's going to be a big one, 56,250. All right, let's go into y equals. You know what, actually, I think I'm going to do this with where you keep breaking it down, the prime factorization trace. Okay, hopefully you all see a 25 in there. So 25, and we're going to divide that by 25, and that's 2250. Okay, so this is going to be 5 rad 2250. All right, hopefully you see another 25 in there. Okay, so now I have 5 rad 25 rad 90. Okay, so that's going to be 25 rad 90. Hopefully you see the 9 in there. Okay, so that's going to give me 3. And so that's going to be 75 rad 10. And there you go. Okay, now hopefully these are going to get a little bit easier. All right, an equilateral triangle has sides of length 2 and an angle measure of 60 as shown below. The altitude from one vertex to the opposite side divides the triangle into 2 right triangles. There's my 30, 60, 90. All right, because the equilateral is a special kind of isosceles. In an isosceles triangle, the angle bisector is also the altitude, is also the median. First question says, are these triangles congruent? Well, yes. Now you have a couple different reasons. So we have yes. You could use the reflexive property and do angle, angle, side. Or you could do angle, side, angle. And this is all going to fall together. All right, so since I have a 30, 60, 90, and we just went over that the pattern is x, x rad 3, 2x. I have to figure out where that 2 goes. Well, if I look at the left triangle, if I go across, it's across from the 90s, so that's 2. That means that if 2x is 2, x must be 1, and so that leaves this one as 1. And this will be 1 rad 3, or just rad 3 is fine. Okay, so what is the length of the shorter leg of each of the triangles? It's going to be 1, and I believe this would be my explanation. Use the Pythagorean theorem to determine the length of the altitude. Well, across from the 60 is going to be rad 3. I don't want to use the Pythagorean theorem. It's going to be rad 3. Okay, so you have to add the b there, sorry. The angle criteria, any 30, 60, 90 will be similar to this triangle. If a 30, 60, 90 has a hypotenuse with a length of 16, what are the lengths of the legs? Okay, so the hypotenuse is 16. Again, we have a 30, 60, 90. X rad 3, 2x. Across from the 90 is always going to be my hypotenuse, so this is going to be 16. which means that across from the 30 is going to be 8, and across from the 60 is going to be the 8 rad 3. And if you want to be more exact, you could do shorter. And this will be the longer. So much faster than doing the Pythagorean theorem. Okay, isosceles right triangle. That's another name for the 45, 45, 90. Oops, sorry. Okay, what are the measures of the other two angles? Well, since I have 90 left and it's isosceles, the base angles must be 45 each. 90 divided by 2. If I really want to explain, base angles are congruent. I'm not going to do that, okay? I'm going to use my 45, 45, 90 pattern, x, x, x rad 2. All right, across from the 45s is the 1. So across from the 90 will be the 1 rad 2 or rad 2. If I want to do the Pythagorean theorem to do this, I would do a squared plus b squared equals the hypotenuse squared. All right, square root, square root. So 1 plus 1 equals the hypotenuse square root of 2. Okay? All right, so now the hypotenuse, actually this is kind of hard. Here's the picture we have that these two are congruent to each other. The hypotenuse is 20. All right? It's a 45, 45, 90, so I'm going to write down my pattern. X, x, x rad 2. And now across from the 90 is going to be 20. All right, so x rad 2 equals 20. Divide by rad 2, and I get x equals 20 over rad 2. Now, hopefully you remember that this is kind of against the rules. We need to rationalize this denominator. So the only thing we can do to not change the value is multiply by 1, but we're going to multiply by 1 in the format of rad 2 over rad 2. So 20 times rad 2 is going to be 20 rad 2. Rad 2 times rad 2, radical flower times radical flower, is going to be 2. So my final answer is going to be 10 rad 2. All I did was simplify right there. Okay, so I think that you should be able to do the problem set, those questions, on your own. All right, so give this a shot, and I think they're all special right triangles. Maybe not 2. All right, so that's what we have for today. So not a very long video, thank God. All right, have a good day.